Welcome back, ladies and gentlemen, to the FRQ enrichment period during our time of quarantine. Today we are going to be looking at the 2018 Calculus BC FRQ number 3, which also had a guest appearance on the Calculus AB FRQs. This was a shared question. This is our classic derivative graph. It's a graph that's the derivative of something else, and we can tell because it actually tells us in the question that g is the derivative of the function f, and the function g is piecewise linear between -5 and 3, and that g of x is equal to some quadratic function between 3 and 6. So let's go and write that down before we forget, because I feel like that's going to play an important role. So g of x is equal to 2 and then x minus 4 squared, and that's going to be true from 3 to 6. They told us that. They also told us, now again, I haven't even really started the problem yet, but I know that g is equal to f prime because they told me that. And so, before we begin A, let's just go and read the conditions. They're telling me that f of 1 is equal to 3, and they want me to solve for f of -5. Well, this is a classic first fundamental theorem of calculus problem where I'm going to integrate. This 1 here, this f of 1 is probably my anchor. I call it the anchor portion because I know what that value is, which means one of my limits of integration is going to be 1, the other one's going to be -5. I'm going to go and put the 1 up here and the -5 down here, and I'm going to go ahead and integrate g of x dx. Now again, I know that that's going to give me f of 1 minus f of -5. With a little bit of algebra, I can isolate the f of -5. If I move some stuff around, I'm going to get f of -5 is equal to f of 1 minus this big hunkin' integral from -5 to 1 of g of x dx. Well, we know one of these pieces. The f of 1 is 3 because they told us that. Now, this integral here from -5 to 1, well, what that is that's going to be all of this space right here, inside this blue, all of this blue space right here. So, how do I recognize that? Well, what I'm going to do is I'm going to go ahead and draw out some shapes, because that's going to help me find the area a little bit better. I'm going to go and just draw these out like that, and then it's going to be added to some triangle that looks like this. Now I got to remember that these shapes down here, these shapes that are looking like they're upside down, these are negative because they're below the x-axis. So what is this? Well, this is a base of, looks like 3, and a height of -3. So that is going to be -9, and that's going to be plus, looks like 1/2 base times height, so 1/2 base, which is going to be 1, and then height is going to be -3, and then plus 1/2 for the upper triangle now, 1/2 base, which is 1, height, which is 2, 1, not plus, but times. So from here, now we just have to figure out what these values are. So it's going to be -9, looks like this is going to become -3 over 2, and then it's going to become 1 right here, so plus 1. And now from here, what I'm going to do is I'm going to go ahead and combine out these terms. So what I get here is -18 over 2 minus 3 over 2 plus 2 over 2. So that looks like it's going to be, -21 plus 2, so -19 over 2. Now this 3 is going to come down. And remember, it's 3 minus this value, so it's 3 minus -19 over 2, which is going to become 6 over 2 plus 19 over 2, which ends up becoming 25 over 2. And that is what your f of -5 is going to turn out to be. Cool. Let's go and move on to part B. Alright everybody, let's go and take a look at part B. So unfortunately I had to clean off the board a little bit because I was running out of space. Turns out part A took more space than I anticipated. But if you want, you can always look back at that question and comment and ask questions if you have any. Part B, it's asking us to find the integral from 1 to 6 of g of x dx. Well, what is that? Well, that's going to be this space right here, this little square, which has, looks like an area of 2 to the right, 2 up, so that's going to be an area of 4. And then that's going to be an integral from, looks like 3 to 6 of this function here, this parabola here, which is going to be a 2, and then x minus 4 squared dx. Well, the integral of this is pretty easy. It's going to be x minus 4 cubed over 3, which is going to be 2/3, and then plus 4 here, and that's going to be evaluated from 3 to 6. So let's go ahead and evaluate this thing. So this is going to be 4 plus 2/3, and then I'll just go ahead and evaluate this thing as we go here. So it's going to be, looks like 6 minus 4 cubed minus 3 minus 4 cubed. So what's that going to turn into? That's going to turn into an 8. This is going to turn into a -1, but he's being subtracted. So it looks like I've got 4 plus 2/3 times 9. So it looks like those guys are going to go away, giving me a 2 here. Oh, giving me a 3, I apologize. And that's going to get me 4 plus 6, giving me 10. So that is the result of the integral. Okay, I am ready to move on to part C. Let me just clean up the board one more time. Parts C and D require more explanation than they do math, so I'm going to use the typing function for this one. Part C, what do they want from us? Well, they want to know on what open intervals, if any, is both the graph increasing and concave up, the graph of f. Well, because f prime is what we're looking at, what we're looking for is we're looking for the word increasing. When f is increasing, that means that its slope, or f prime, is positive. So what I'm looking for initially is anything that's above the x-axis, because anything above the x-axis is positive slope value. Anything below the x-axis is going to be negative slope value. So in fact, I'm going to type that in. I'm going to type that in case we forgot. In case we forgot. That's positive slope value. And then that means that anything below the x-axis will be negative slope value. Anything below the x-axis is negative slope value. Oops, crud. And now, from here, if I'm going to look for something that's concave up, well, concave up is the second derivative. So we're looking for the derivative of this guy, meaning the slope of this guy. So if I'm looking for something that's concave up, I'm going to be looking for where this function is increasing. So putting those two ideas together, I'm going to be looking for where this graph is above the x-axis, making f prime positive, and increasing, making f double prime positive. So where does that happen? Where are we above the x-axis, simultaneously moving upwards? Well, if I'm a betting person, I'm thinking that it's going to be f is both increasing and concave up on 0 to 1 union 4 to infinity. Now, you can go and do the sideways infinity sign. I cannot do that on the typing program, but then you just have to justify it because... Now, here's where you want to be careful. If you don't establish the relationship between g and f prime, you are liable to lose points. So I would say g equals f prime is both positive and increasing. And that just about does it for C. Part D, it says find the x-coordinate for each point of inflection on the graph of f. Give a reason for your answer. And so, in this case, it looks like there's only one point of inflection here. It looks like it happens at x equals 4. So you would say f has a point of inflection at x equals 4 because f prime changes direction. You could say f double prime equals g prime changes sign. You could say that. I try to keep things simple. It's up to you. There was some confusion over this problem last year because some people thought that a sign change indicated from positive to 0. A change in direction directly is going to indicate a point of inflection. So you'd have to go from positive to negative, not positive to 0. So just keep that in mind. I thought this was a pretty light FRQ. If you have any questions, leave them in the comments. And hopefully you guys are staying well and healthy. And I will see you in the next one.